All right, welcome everyone. Thank you for joining for our final presentation of the week that is a keynote. And I'm just so excited to have you all here and our guests as well. And I'll hand off to them in a moment. I just want to get your fingers warmed up for the day. And what I'd like you to type into chat, if you have a moment and you can think about it, is whether or not you're joining us for the closing celebration this afternoon, which I hope you will. I hope you'll join us for the closing session too, which starts a half an hour after this keynote ends. What would you have as a celebratory snack or drink for such an event, especially if you were in person? But what will you bring with you maybe to this upcoming thing? What I would do if I had any, I would bring cupcakes personally, but you can type that in chat. Just so you know, later in the session, we will be taking your questions and they'll be coming straight to the host, and that is me, and we'll be passing them along through Alan. So with that, I will watch what, oh yeah, this all sounds so delicious. So with that, I'm going to hand it off to Alan Chalker. Thank you, Alan, for being on top of things for me.
Thank you, Catherine. And by the way, I think we all very much owe a round of, maybe thumbs up or something in reaction for Catherine. This is the end of what's been an amazing week. If we all have maybe if you have your signs, the way to go sign, she has worked tirelessly to coordinate this over the past few months, and very appreciative. It's been a great event. So thank you, Catherine.
Thank you.
Okay, so I am super excited about this plenary, and let's start before I even introduce our speaker here. Let's start real quick and do a quick show of hands. You can use your Zoom reaction button, or if you want to chat. How many of you have an actual GitHub account? Let's just get a general feel for that. And I see.
And they can do that with their hand thing. Yep.
Yep. We're popping up multiple. Oh yeah, there's quite a few of them popping up. Yeah, oh, and I see people are raising their hands, thumbs. Quite a few. Not surprised that the majority of the audience have these GitHub accounts. And part of that is because, as of earlier this year, I think GitHub reported 40 million users, and worldwide, 190 million repositories. So it is the largest host of source code in the world. And so speaking to us today, we've got Thomas Donkey. Thank you so much for joining us. He's Vice President for Strategic Programs at GitHub. And our initial reason for inviting him was not because of GitHub as a tool, but because of something else that you're going to hear about here in a second. We're going to talk about that. But in particular, how many of you have noticed, maybe if you logged into GitHub recently, that you might have a badge that says Arctic Vault Contributor? I see lots of shaking hands. Yeah, lots of shaking heads. Yep. Well, that's what he's here to talk to us about, which, one of the special projects they have is the archive program. Now, prior to working at GitHub, he was also a director at Microsoft. And, so with that, I guess, Thomas, welcome. Thanks so much. We're going to have a dialogue here. This is not really a big presentation. So welcome so much. Did I miss anything in your bio that is important that, you wanted to call out that you're especially proud of?
Ooh, well, first of all, I'm happy to be here, and I love I love seeing everybody on the Zoom video, and it's actually 50 million developers now on GitHub. So we're still growing fast. The world is growing fast. Software is so important. You can hear from my accent, I'm a German guy. I'm originally from Germany. So bear with me sometimes when I'm not finding the right word. And I live in Seattle in the United States right now.
Okay, great. So I'm going to be fielding some questions to Thomas. You're welcome to put some into chat, and those will get filtered to me via Catherine. So let's just start right off. And tell us about the origins of the Arctic Archive program. What's the story of how this came to be, why it's important, all of those things around it.
Yeah, in the last year or so, we have come to the realization that software dominates our lives. In a way, since COVID started, even more so, software is completely dominating our lives because all our work life has moved to a remote-only setup where we're communicating through Zoom chat, video chat, and Slack and other tools all day in and out, and we no longer meet people in coffee shops or have casual conversations at the water cooler. But if you think about your daily cycle, it doesn't even have to do with work. When you wake up in the morning, your alarm probably is coming from your watch or from your cell phone. The first thing you probably do is grab your cell phone and check the news or browse through Twitter or see some emails. You communicate with your whole family and your friends and everybody through your cell phone or your computer. You set your thermostat, you track your run outside, the weather, everything is really dominated by software today. And that's only, you can go on and on with like ordering food and ordering anything really, groceries, tracking, plane flights when we still used to travel, checking your hotel reservation, the hotel key, everything is software, and everything is software in our work lives, of course. And so software dominates our lives. That's kind of like the first insight that we had over the last year that started this thought process of the archive program. And then we looked, into what is the software consisting of, like what's part of the software, and we figured almost all projects today are reliant on open source software. No company can afford any longer to not pull in dependencies, libraries from open source projects. If you want to, start a company and reinvent the wheel and do everything yourself, so you have no chance to compete with other companies in the tech industry, or outside the tech industry. We actually think no major innovation will ever happen without software again, because worst case, right, like the only software involved is your publishing process and how you announce a product. But really, in a lot of projects and a lot of ideas, you pull in software today. And last year, right before one of our conferences, this picture was published in the internet, and I'm sure most people here on this call have seen this. This is the first picture of a black hole, and it went around the world, and we saw this, and we were like fascinated by the sheer imagination that there's this black hole out there, and we can now prove that it exists and how it looks. And then there was another picture, which is Katie Bauman, one of the researchers of the science team that discovered this black hole, and you can see her sitting here, in this moment where they found the picture, and you look at her laptop, and I don't know about you, but like I identify myself with this picture. Like you see like the code in there and a command line, right? It's really software. It's research through software, and because nobody in that team traveled through space to the black hole and took a photo, they used software to do that. And a lot have been said about this team, and they did great work. But if you look at what they did to get there, is that they used open source. They used lots of Python libraries, and some of them are listed here. And I apologize that because we are not in presentation mode, all the type correction is shown here. And if you basically look at all the libraries that contributed to the source code that the EHT team has used to discover the black hole, you figure out that there were 21,485 community contributors that one way or another wrote some code that helped the EHT team to render this image of the black hole. Right? And so we thought, man, this is fascinating. Basically, you have a science team. It's like 10 or so scientists around the world. And then you have 21,000 people in any country you can imagine that are contributing code. And they're not doing this, with the goal of rendering the black hole. They're doing it because it's fun for them. It's part of their hobby. It's part of their work, writing those libraries and sharing them with the world. And so we looked, how does that look for other projects, right? Because often, when we talk about a software, we think about the team that's sharing that with the world. It's often a small team, and it's kind of like the iceberg. On the top of the iceberg is what we are seeing. but if we really dig deeper into the dependency graph, all those dependencies that are contributing to, and we sampled 1,000 GitHub projects, we figured out in those 1,000 projects, the average is 74,000 contributors. So the black hole image is actually on the smaller side, and lots of other projects, big projects, have 74,000 contributors. And that's more developers that Microsoft has. That's more developers than most of the Fortune 500 companies have. And so the takeaway here is that you can no longer compete in the market if you're not using open source. Open source has won. That's the message here. It has gone from this, idea of a few geeks in the 90s, this movement of free software and liberating the world from, the big software companies that hide away their code and make you buy a license. It has come from this movement to everybody is using open source. They have to depend on open source, and they have to be part of the open source community. That's like the one takeaway. The other one is that, when you write an import statement as a developer, what you're really doing is you're giving somebody else access to your code base, right? You're pulling in those contributors into your code base, because as soon as you import a library to your code, to your project, you're also depending on updates to that library, right? You're updating that library all the time. And so every time somebody on the other side of the planet has made a feature update or a bug fix to the libraries I'm using, I'm pulling up in those updates. And so in that way, I'm collaborating with all those people around the world on my project, on my startup idea, on my research project, right? And so it's really this interconnected community of developers that are collaborating around the world with no boundaries whatsoever. Right? I mean, that's like, I don't care who's sending me a pull request. I don't care who's, filing an issue. As a developer, I want to see the code, and I want to get feedback on my code. And so we really recognize that open source not only has won, it has also changed of how we do open source, of how we do software development. And we don't think there's ever a way going back. But of course, if you travel in time, into the past, into our history, you know that we have lost knowledge, right? This is a picture of a dome, the Grand Dome in Florence, and it was built. I actually have to look that up here. It's like 1418 or so is the date when the leaders of Florence set up a contest, and they set up a contest, and they wanted to find the best builder for their dome. The dome is, the roof of the church here, and they did a contest, and no such massive dome had been built since the Roman Empire, right? And so the contest was won by a guy called Filippo Brunelleschi, and he had gone to Rome and studied, the ruins of the Roman Forum. I actually did that myself last year as well, and it's fascinating, right, to see the remains of this Roman civilization there. But you also realize we have forgotten a lot of that knowledge, and we only found out 1,000 years later what the Roman civilization had achieved. And we studied this by studying the ruins. We didn't had like books or discs or whatnot that we could look into. Like there wasn't an archive that the Romans had left for us that we could study. And so we had that realization that humans forget. Like we forget because we are lazy. We forget because things have moved on. You can only go like back 100 years, and how much do we actually know about our ancestors that have lived 100 years? How much is that part of our life today, right? And so we realized we have to do something. We want to preserve the knowledge of open source development. We want to preserve open source itself, the source code, for generations to come, to enable them to study how we lived in the early 2000s.
Wonderful. And I know actually you didn't mention it here, but you talked about the Library of Alexandria as a great example on the actual archive program website of something that's been lost over time. So let's talk quickly about your role in particular. I think you've set the stage wonderfully for what the kind of motivation is, and I saw lots of nodding heads and thumbs ups throughout that. So what about your role in particular with this?
Yeah, so I run a small team of project managers, if you will, or computer scientists, software developers. They're like generalists, if you will, in our space. And we call ourselves strategic programs or special projects. we are basically running the ideas that our normal product development team doesn't have time for, because they want to ship cool new features. We just recently, for example, shipped code scanning, which is a feature that allows you to find security issues in your code, or we open sourced our documentation. So my team doesn't do all of this. We have a product team and an engineering team that take care of all of that work. And instead, we are taking care of, other projects that recognize the importance of open source for GitHub, and that recognize a strategic value to the company. So we are doing acquisitions, amongst other things. We have done this archive program, and the archive program is not done. It's an ongoing project that we expect, for many years to come. It started actually about a little bit over a year ago. It was the time when we first went to Svalbard to do the very initial drop there.
Well, since you mentioned Svalbard, tell us a little about how the location was chosen. And for those of you that didn't get a chance to, by the way, there is a wonderful video about this that was included on the Kiko Chat plenary page that I'd highly recommend you go take a look at if you didn't get a chance to see it. But go ahead, tell us about that some more, please.
Yeah, so we are software developers by heart. We're all software developers. We're not archiving experts, and so we did two things early on in the project. One is we looked for experts in the industry, archaeologists, scientists, people that have experience with archiving things, people that can give us insight of what's important to preserve software, because it's not only about putting it into like a data center or on a disk. It's also what do people in 2,000 years do with this, right? So we created a panel of advisors that helped us run this program, or that are helping us to run this program. And then we looked in, who are the experts in archiving data, like, and what are they doing? And so we basically did like a research and looked through the world. And if you look on YouTube, there's one very known project, the Global Seed Vault, which is also on Svalbard, where over 1 million seeds are stored there from all the local seed banks. It's kind of like a backup drive to all the local seed banks. So if something happens to them, like a power outage or a local war or something, there's still a copy of that seeds stored on Svalbard. And so we found this company, Pickle, P-I-Q-L, which is a Norwegian company. They're archiving experts, and they have this film technology that you can see here on this picture, which is silver halide film, and it's made to last about 500 years under normal conditions. If you put that film and then the film reels into like your archive, like a library or like an archive room, in the basement of your house or so. But under the conditions in Svalbard, in the permafrost, it actually lasts much longer than that, because a very stable condition, temperature, humidity is very stable. And so we think the film reels will last at least 1,000 years. So we picked this partner Pickle, and they're helping us to run this program in Svalbard. Now, if you don't know where Svalbard is, we cannot put a world map here. It's an archipelago north of Norway, and it has a very special international status coming from World War I. Where it isn't really part of any country. The Norwegian government is managing the archipelago, but you can actually travel there without having a passport, because it's not part of any country. It's an international zone. It's a little bit challenging to actually do that, because most airlines require you to show ID, and you have to connect to either Norway or another country to get there, and which naturally means you have to have a passport to connect to those countries. But on the island, there is no border control, and so it's in the Arctic Circle. At this time of the year, it's mostly dark. The sun is not coming up, and they have coal mines. The only industry up there is coal mining, and a little bit of fishing. But there's no vegetation growing. There's no wood. They have to import everything by boat, by ship, or by airplane from Norway. And most of the coal mines are decommissioned, right? They're empty. The coal is gone, and they're now working in the next the 5th coal mine. And so one of those coal mines is hosting what Pickle calls the Arctic World Archive, which is an archive with documents from certain entities. For example, the Vatican the Vatican Library has stored like copies of their documents in that decommissioned coal mine in the archive. And so this archive is basically where we now put the open source code on the silver halide film. It has very stable conditions. You can technically access it without any tools. The coal mine it has an entry, and you basically walk down the shafts, and it's kind of like goes up and down, which is great because even if there's meltwater, climate change is coming. We all agree with that on that call, I hope. So even if the permafrost is melting a little bit, it can flow down because it's basically trapped in those shafts that go up and down. And then the entry to the mine is actually 100 meters or so above sea level. So even with rising sea levels, we expect that water cannot enter the entrance of the mine. And then you have the stable conditions of the permafrost. The archive itself is protected through like a security gate, and then within the archive, and so you can actually see that here. You can kind of like see here how the film reels are stored. So those aluminium bags contain a plastic container, and that plastic container contains that silver halide film. And yeah, so going back to this, sorry that this is not animated because we're not in presentation mode. The only ice bears, polar bears we saw were those stuffed animals. They have like thousands of polar bears up there, but in winter you cannot see them near town. In summer they come out. So yeah.
Sure. So you spoke a little bit about the materials and the technology. Can you share a little bit more details about, what is the actual, I don't know, you said there's QR code. How do you capture that content, put it on the storage? Is somebody going to read it off? And then maybe also what future visions, what future materials you might use for this archive? You said it's going to continue on from year to year.
Yeah. It's a great question. So the reason we picked the silver halide film is that you don't need any technology to read it. And you can kind of see this on the picture here, right? You can easily, detect the GitHub logo and the pickle logo here. And you can see it's tiny, but as long as you have a magnifying glass or a good vision, you can read what's written on there. And so there's two ways of store data we're using two ways of storing data on this film. One is human readable text, and we actually translated it in 5 languages, including Chinese and Hindu, Spanish, and Arabic, and English, of course. And it starts with like an introduction, a manual to the archive. So if you imagine you find this, in 2,000 years, and you open it and you think, what is this? And you basically roll up the film and you can start reading what's written on there, and it explains to you what it is. And it explains to you what it is in 5 languages. And this manual not only contains a description of the archive, it also explains to you what software development is. It gives you kind of like a Rosetta Stone of software development, and we call that the tech tree. So it's like a collection of books. It's a collection of how-tos in material programming language, how to learn C or how to learn Python, that lets you dive into the subject matter, and in theory at least rebuild our software ecosystem from scratch. It obviously will take you a long time unless you have like very advanced technology available to you, right? But you can, if we believe in the future, like Star Trek, maybe it's just a tricorder that you hold onto the films, and then it does everything for you. And then after this human readable text, everything else, the code is stored in QR code, and so you get a higher data density. And it's basically easier to store zeros and ones in QR code than it stores to text, because the ASCII rendering takes up more space. But of course, QR code is still human readable. It just takes time to decode zeros and ones, and you can do that with paper and pen, or you can do that with a machine. And so basically followed by this introduction are all the active open source repositories from GitHub. So everything that's open source, not private source code. So if any of you have like a private repo, that's not stored in the archive, that's your private stuff. We're not accessing this in any way other than our normal data center backups. But everything open source that had some meaningful contribution in the last year, or is so important that it has more than 100 stars on GitHub, which is like a like on Twitter, is stored on the archive. And so it's about 200 film reels that are stored in the archive with all the source code. And so, how did it get there? So we literally, took a backup from our data center and stored those open source repositories on 2 hard drives. That was back in February. So on February 2nd, 2020, so 2/2/2020, we took a snapshot from all the open source repositories, right? It's obviously not real-time data in the archive. It's a one-time snapshot for now. And we stored those on those disks. It's a cool shelving. You can kind of like imagine like a movie where somebody carries that case to the airport. And then we shipped this to Norway, and then the company Pickle in Norway read that data from the disks and produced the film reels. And then the pandemic hit us in March, and so we're actually planning to be there for the drop of all those film reels. But instead, we couldn't travel there. Most travel is locked down, and you couldn't enter Norway by the time that we wanted to do the drop in July. So instead, we had Pickle do that for us, because they're living in Norway. So they once air travel was possible again between Norway and Svalbard, they packed everything in boxes, and they literally loaded the boxes onto a passenger plane. That's sometimes much less exciting than it sounds. It's just boxes going into a passenger plane, and then a truck unloaded those at the entrance of the mine. So you can this is looking out from the mine to the outside, and I think we have a picture here. You can see here how that looks. This is the mountain where the mine is in. Actually, at the bottom right corner is the airport, and on the bottom left here you see the Global Seed Vault, which has this super fancy, futuristic looking entrance. And back here, this is the mine, and those are the mine buildings. And basically, you enter from the front of this hall and walk into the mine. Yeah. So they did the drop for us. I think I already showed this picture. And now you can imagine, hovering over Svalbard are all those open source repos. The interconnected community is resting there in the coal mine.
Okay, so we've got two, related to what you just discussed, we've got two questions from the audience that semi-relate. One of them is somewhat tongue-in-cheek that I'm sure you're going to use that, and that's that how do you differentiate between tabs and spaces on the code that you've encoded on the film? But I think that I knew you'd laugh at that. I think that the bigger question that was really asked and I think this relates to the tech tree that you were talking about, is how do you really ensure that somebody that's bringing back that software can be able to execute it, in terms of, what about the fact that there's different library versions, or there's different, what's the sustainability of that and long-term assets? Can you speak a little bit more about that, please?
Yeah. Let me answer the tech versus spaces question, because let's geek out a little bit, right? It's a science conference. It's QR code, so a space has a different ASCII character than a tab. So a tab is one ASCII character stored in the QR code, while if you did 4 spaces, you have 4 ASCII characters or UTF characters for those 4 spaces. So if your spaces actually took more space, took more space on the film than tabs. So those that prefer tabs, they win this argument. If you ask me personally, I prefer spaces nonetheless. And so that's the geeky part of the answer. The executing it in 2000 years. So I think, there's there's multiple versions of how the future will end up. Which, in the optimistic one that we want to believe in is that it's not about we lost everything in 2000 years and we have to rebuild civilization. Instead, it's about studying how we worked together, how we interacted, how we collaborated, how source code was written, because you can kind of assume that, in 2000 years, we will no longer write software the same way we do today, right? Like if you only travel back 100 years, nobody had like a keyboard and a Zoom call, anything like that. And if I had told you this in 78, that we would all be sitting on video calls and writing source code as part of our work life, you probably would have thought I'm crazy, or maybe you would have thought, this is in 2020 we are already further ahead and somebody else is doing that for us. So we can kind of assume that software development will massively change over the next 2000 years. Maybe it's AI writing code for us. Maybe we have found completely different input paradigms. We already shifted from kind of like having keyboard and text terminals to having a keyboard and a mouse and a keyboard and trackpad to now having multi-touch devices in our pocket that are way more powerful than anything that we had on our desk just a few years ago. And so we can kind of see a future where software development has evolved so much that people have just forgotten how it worked in 2020. So that's the number one. And I think then the archive serves more like as an archive, like a library, a museum, to understand how this worked, instead of using that source code to rebuild a computer from it. That said, that we did store the dependency tree. Basically, if you, for example, take Bitcoin here, which is because it's shown in my graphic, it's not only Bitcoin source code that's stored there, it's also all the libraries that Bitcoin is using and that are open source that are stored. So for example, the C compiler, or a mathematical library, or a library to encrypt, do crypto or encryption of things. So all those libraries are stored there. So in theory, you can go and start decoding all those QR code, and so you're filling up a disk again with source code, and then you have to do a lot of work yourself to basically compile that code. And the biggest challenge will be in 2,000 years to find like an x86 computer that is actually able to have the same instruction set. So either you have that in the simulation and somebody has maintained all the virtualization solutions between now and then, or you can also find the blueprints of those computers, the instruction sets and whatnot on the archive, and you basically start building a new CPU that enables you to run that code again. So it will take a lot of effort, like even in the same way that it took us a lot of effort to decipher the pyramids or to decipher the Roman Forum, and so this only gives you a trigger to help you with this and information, but we're not solving all those issues for the future generations. That said, and I think it's a good way to transition a little bit, is that in addition, the Arctic Code Vault is only one part of our archive program, and we announced this archive program almost a year ago, November. And it has different layers, and we actually got the idea of those PACE layers from the Long Now Foundation. Stuart Brand, who is one of the founders of the Long Now Foundation, came up with this concept of PACE layers, and they describe how often you archive something and for what purpose. And so we have this cold layer, here's the Arctic World Archive, where you archive it for 1,000 years. So it's obviously not often, because you cannot, the effort to archive this amount of data, print the film reels and so on, is expensive, but it also takes just a long time, right? It takes time to print those film reels and get them to Swell, but you can't do that. You can't do that too often. So obviously your data is stale after a couple of hours, but in the same time, the data lasts almost forever, like 1,000 years, maybe it's even 2,000 years. And so this is like the cold layer, right? It's slow, but it lasts long. And similarly, we're working with libraries like the Bodleian library, or you mentioned the Library of Alexandria, to also put a subset of repositories into their shelves, right? So they are experts. The Bodleian library has been archiving books and other materials for hundreds of years, and so they will also archive 2 film reels or so. And then, as we grow warmer on this spectrum, on the PACE layers, we are working with partners like the Software Heritage Foundation in Paris and the Internet Archive in San Francisco. And I'm sure you have used the Internet Archive to go to the Wayback Machine and look up, how certain web pages looked like 10 years ago, or now it's almost 20, or 20, even 25 years ago. 1995 was the first web page. So you can look at all your old personal web pages, my first in HTML, and how crappy that looked. You can go back in time and still see GeoCities and whatnot. And so those partners, they're able to archive much more often, right? It's not in real time, because that's still a lot of resource that have to be involved to stream all the data in real time from GitHub into their archives, but they can do it on a monthly basis or on a snapshot when they detect a change to a web page, in the same way that the Wayback Machine works today. And so the Software Heritage and the Internet Archive, they're archiving all the public repositories on an ongoing basis, and it's easily accessible for anyone, right? You just go to their web page and you say, I want to see, how Matlib looked 3 years ago, and you get access to that version of the code. And then the Internet Archive will actually go a step further and have full Git repositories. So you can even clone it from the Internet Archive instead of cloning the repository from GitHub. And then at the top of the layers, obviously our own system, and we not have only one data center, we have multiple data centers that store multiple copies of our source code. So if one data center goes down through lightning strike, you just have a seamless, or hopefully seamless, experience of that data, of a second data center taking over, and GitHub doesn't go down for you. And then obviously also in any modern data center, you have like tape backups and backup drives. So we have like whatever 30-minute backups from everything and all the time. But in the hot layer, we also work with other partners. 2 of them are GHTorrent and GHArchive, which are streaming data from our API or application programming interfaces into big data databases. And so they're looking for all the events that are happening, like Alan creating an issue, or Kathleen creating a pull request, or John, putting a thumbs up on a feature request. They're streaming all that metadata into a big data database, either Google Big Data or Microsoft Azure Big Data. And that's cool, because you can then use a query language to do research on that data, right? You can find out how people collaborate in different time zones. You can find out that productivity goes down as soon as we switch from daylight savings time to standard time, because now our cycle is shifting. Like this, there's actually papers on that where you can see there's like a drop of productivity in November, and then it goes up again in March. And we looked on this closer. It was actually a Microsoft research paper, and we figured, oh, it's exactly the day when we're switching to daylight savings time and back that the productivity shifts. I think it was like a significant percentage that the productivity shifts because people now have this different biorhythm. So you can use those big data databases, and they are in real time because they're streaming from our API. They're looking for webhooks and for data to stream from our API directly into those big data databases. So we have all those layers and all those partners, and in that way we have a comprehensive archive, and you basically don't have to rely on the long-term storage to rebuild your software. Hopefully, the software heritage gives you access to binaries and to executables even in 1,000 years.
That's, it's so obvious. Of course, there's going to be a change of productivity, but to be able to actually analyze that is so cool. So let's kind of talk a little bit more about that. That you obviously are doing some sort of research, some sort of analysis. You have all kinds of stats on this. So and I don't know if you have more that you want to share here, but are those actionable? Are you learning things from that? Are there things that we can learn from what you're finding as you look at this?
Yeah, I mean, like I would say my team is not doing research on that data. That's other teams. We are providing the data to them, and other teams are doing the research. We're enabling their research. So Microsoft has a research team that's looking into developer productivity. But there's lots of university-based team and other institutions out there that's looking at data and understanding how we collaborate, how we are now bridging the boundaries between countries, because developers are like just collaborating and don't care about politics between those countries. And so we are enabling that research. We're not doing the research ourselves. We're more interested in adding more features to GitHub and adding more features to the archive and enabling the community to do the research themselves. What we are learning, I think, is that you asked in the beginning if people have seen that badge on their profile. I think being an open source contributor, being part of the open source community is a badge of honor. People are proud of doing this. They're proud of doing this, and they're doing it in their free time. They're doing it from a lot of intrinsic motivations because it's fun to do it. And this is what we want to recognize here. We want to recognize the moment that open source has won, and we want to recognize the moment that so many millions of developers around the world are contributing to open source all the time, creating new value for all of us, right? Because as I mentioned earlier, when you work on a mathematics library, you're not doing this because you're thinking, oh, somebody else could use this to render the black hole image or could use this to start their startup. You're doing it because it's fun for you. Maybe it solves a problem for yourselves, and then you're sharing this with the world with the motivation that somebody else can use it. And then hopefully, that somebody else, the benefit of open source is that you can see the source code, but you can contribute back to it, right? You can send a pull request and says, hey, I found a bug here. I found a typo in your README file. I added a feature that I needed, and maybe you find it useful too. That is the power of open source that we want to recognize through the badge, but more so through the archive program itself.
I think that's a great point, Thomas. And so I guess let's take that a step further. As many of us are developers, many of us are contributing. We have gateways, science gateways that we're creating that we're storing on GitHub. But is there anything that we should do to give more thought to how we preserve, how we ensure that the outputs of this are contribute to the broader community knowledge? Do you have suggestions, things that I guess maybe we can do to facilitate that be part of the team as opposed to just somebody that's dumping it into GitHub?
Yeah, I think it starts with when you create a repository on GitHub or on any platform, doesn't matter whether it's GitHub or not, and you share something with the world. Think about what license are you sharing it under. Like a lot of repos start with just a couple of files, and then you don't know what the license is. And just because you're making it public doesn't mean it's actually under an open source license. And so pick a license early on into a project so other people contributing to this or using it have a legal foundation to use that software, but also feel confidence that you're not one day saying this is just public domain, but you have no right to use it in commercial software. So pick a license. And I think, that's a conscious decision that everybody has to make, whether you want to pick the MIT license or BSD license or a more strict license like the GPL. But pick one. I think that's number one. Number two is, I think a lot of successful open source projects, if you look at how they run, is that they have a very clear README that not only enables people to get up and running with a project, like, what you can do on your local machine to check out the code, to compile the code. How do you get up and running? Because if you want to contribute back to something, you better make it easy for people to run that code on their local machine. But the other one is also, you want to set some guardrails for your community. Right, you want to tell people, this is how I expect a bug report to look like. This is how I expect, to send feature requests. And you can also set expectations as in, this is a spare time project for me, so please be with me and give us 24 hours or like 7 days or so to review your pull request. You want to kind of set expectations with the community in a friendly way, but it's it's better for people to, because otherwise people get frustrated, right? They send a pull request and then they're like, why is Alan not responding to me? This is such a great code. Why would he not merge this in? So you have to set clear expectations. Otherwise, you as the maintainer will quickly get frustrated with the community, right? And we all have lots of things going on in our lives, even more so now during COVID. We are stressed out. Like the kids are at home and they need to learn in school, but there's no teacher in your house. The teacher's on the other side of the Zoom call, and so you still have extra responsibilities there. So set expectation to the community to make your life easier, to make it still enjoyable for yourselves. If it's not enjoyable for yourself, it's not long-term sustainable. And then I think the third kind of thing the third point I want to make there is that, don't be discouraged by something else already existing, right? Like the internet is so big now, and the space of open source is so big now, that if you just look long enough, you always find something that already exists. But that doesn't mean that this something that already exists is better, or it's still maintained, or it solves all your issues. So I encourage you to not get distracted or demotivated from finding other projects. And then the cool thing about GitHub is that you can fork this project, assuming the library, the license allows you to do that. You can fork the project and use it as a foundation to build on top of this. You can also take some ideas and build your own open source project, whatever makes sense for you. But don't be discouraged by the sheer mass of existing project. There's always something more you can add to an existing project or to a new project, something that you have a different perspective, you have a different background, where you can add something that other people haven't seen.
Great. I just want to remind the audience that you're welcome to send questions via chat directly to Catherine. She's feeding them to me, and I've been working several of those into the conversation here, not necessarily supposed to be saying that, but we do have a couple very precise, specific questions that I haven't been able to work in that we wanted to give you an opportunity to answer. So the first one is, can you quantify the data? How much data have you actually archived onto all those reels of film?
Shoot, I want to say it's 20 terabytes. It's something like that. It's like in terabytes range. I think it's 200 film reels, and I want to say it's 20 terabytes. I had that number ready, but I'm just blanking on it.
And when I'm sure everybody's asking and thinking, is that 20 terabytes of compressed, uncompressed, QR code?
It's basically the hard drives that we sent to Pickle had that much space on it, and then they printed it onto the film reel. So it's compressed in the sense that it's a QR code, but it's still readable. It's still readable data. It's a tar file. I believe it's yeah.
Okay, sure. And then what did you actually archive in terms of, obviously, the code? Have you archived versions, issues, GitHub pages, things like that as well?
Yeah. So we have archived the source code from the repo. It's called the head revision of the default branch. So it's not all the branches, it's not all the revisions, because that would be way bigger than you would basically fill the whole mine with just film reels. That's how much data that would be, right? Like, so the 20 terabytes is the head revision of a repo. So it's basically one local copy of that specific version on February 2nd, 2020. It's all the issues, and then you ask about pages. So a GitHub page is also just in the repo. So as long as the GitHub page was stored in the default branch of your repo, that would also be stored in the archive.
Okay. And I think you slipped this in earlier, but just to be explicitly clear, you only archive public repos, correct?
Correct. And just to be clear, right? When we talk about the archive here, we mean the Arctic Code Vault, right? So in the Arctic Code Vault, we have those restrictions. For all the other partners, it's way more data, right? If you look into the software heritage in the Internet Archive, it's the full repo with all the revisions in almost real time. And then if you look into GHTorrent and GH Archive, the data is even streaming more live, so it's even more data, right? So we are like if I go back here in my deck to these space layers, right? The Arctic World Archive stores the smallest amount of data for the longest amount of time. GitHub has all the data, and then in between those layers have more data in shorter cycles than the archive. But yeah, on the mine you have all the issues and the header revision of the source code. And just found the data. It's 21 terabytes. In the
21 terabytes. Very good. Very good. Okay. And then you also made a comment earlier, at the very beginning, I want to come back to, that you talked about a certain percentage of software is open source. And one of the questions from the audience is that based upon just what you're seeing at GitHub, or is that a more community level analysis? We're just trying to understand the genesis of that analysis.
Yeah. So it's not scientifically perfect, right? We only have a certain amount of data. So we sampled a number of repositories on our site to see how much of the projects, whether they are open source or not, are having dependencies on open source software. And so we believe that 99% of projects that we sampled have some kind of dependency with an open source, with open source. And that could be now pulling in a library, an open source library, using an open source compiler, running on an open source operating system like Linux. So it's a sample, but we obviously know from GitHub itself and from Microsoft what our software ecosystem looks like today and how we are building software. And so we are pretty convicted that that number is mostly accurate, that most of the software projects today have one or another dependency on open source.
Sure, it makes sense. Okay, the next question from the audience, it goes to the age-old idea of it's not sufficient to back up your data. You need to actually test that you can restore the data. So questions about, have you looked at retrieving and compiling or integrity or kind of, some sort of regression test of what you're storing?
Yeah. That's a good question. So for the Arctic World Archive, we obviously haven't gone through the coal mine and pulled out the data after it had been dropped there in July to recompile that data. So what's in the Arctic is there, and if you take it out and to regression testing, you would reduce the lifetime of those film reels because they're no longer under the stable conditions. We had a test film reel from Pickle, and the way that works is if you want to decode that data today and you have access to modern technology, Pickle actually has a machine that you can use to reread the software from the film reel, right? So basically, instead of doing that manually with a pen and paper or with a magnifying glass, you can load that film into a machine and basically decode the data on the film and put it back onto a disk. And that, it's the same source code files that you would check out from a repo. Now, if you're asking, have we gone through all the thousands of projects to see if they are all still compiling? We haven't, but we haven't also checked whether they were compiling before. We're not going to that level of detail in terms of compiling all the source code on GitHub to see if it's actually compilable. But we did go through the process of rereading the code from the film reels to see if that actually works and if you can read the data.
Okay.
And then again, look into the archive. Obviously now with the other partners, it's much easier to do that, and we have done tests, for example, on those real-time databases to compare them against the data that we have internally.
Sure. There's a comment that's been passed that I hope you know what this means because I just don't, and that's that the audience might be interested in the Octoverse report. I don't know if you can speak to what that is, and we can put a link in the chat about it.
Yeah, so the Octoverse is a yearly report that GitHub publishes usually around our yearly conference called Universe. I don't know when we're doing it this year, but it should be coming in the next couple of months. And it's a state of the open source ecosystem. So we're basically publishing interesting data from GitHub that we can see in our data sets, like what are the most, what countries are giving the most contributions, what countries have grown year over year faster than other countries. You can kind of see, the impact, for example, that Asia is having lots of computer scientists coming out of universities in India and in China, and so you can see how open source is growing in Asia versus United States. You can see the most popular open source projects on GitHub in the last 2 years. That was a Microsoft project called VS Code, which is a code editor, an open source code editor that Microsoft provides. It's written in JavaScript, and it's very popular as an open source project. Has, I want to say, over 15,000 contributors in the last Octoverse. So we're publishing this report every year, and it has super interesting data. If you Google Octoverse, you can probably find it, hopefully.
It's octoverse.github.com is what I've been told here. So we can thank Nicole for that. Okay, we only have a few minutes left in the hour, and I guess I wanted to take the opportunity to just ask you if you can share anything about new initiatives or future plans. You know, for example, you've got here on the slide Project Silica. Anything you want to talk about just as to where this is going in the future and what you're thinking about?
Yeah. So Project Silica is a research project where we're partnering with Microsoft on even longer term storage options. You can see this here on the slide. Silica is a glass disk, and data is stored in on that glass disk in the molecular structure, and it's a laser that's putting the data into that structure, and it's pulsing a quadrillion times a second. So that's 1 followed by 15 zeros. So the laser is super fast, pulsing and storing data in the molecular structure and of that quartz platter, of that glass platter. And there's two main benefits here. We know glass we understand very well. We know how long glass lasts, and so the estimates here are that those disks will retain the data for 10,000 years. And they're obviously also much smaller than a film reel, right? Because you can imagine the molecular structure can store so much more data than a film with human readable text on it. And that's obviously also the downside, right? It's not human readable. You need some kind of machine, and in fact, the machine needs to be running machine learning algorithms to even be able to decode the data out of this disk. Like it's harder to decode the data, but it's storing data much longer, and it's storing it much longer under very different conditions. Like you can store those disks almost anywhere around the world to last 10,000 years. And so that's one project we're working on. Microsoft had shown that at their conference last year, and they printed the Spider-Man movie onto a tiny disk. It will take some years until this is production ready at the scale we would need to store all the data. And then we will store those in different locations around the world once we're ready. So that's coming. It will take some time, but basically we will have, similar to the Global Seed Bank, multiple copies of our archive stored around the world. In addition to all the layers we already have. We keep working with those partners. It's an ongoing project. If you go to the Internet Archive today, you find a subset of our repos. So it just takes time, to copy and transmit all that data. So that's an ongoing project. And yeah, we are just. I think we will also reevaluate the project every now and then. Deciding whether we want to go back to Svalbard and do another drop there. Obviously, we can do that every 3 months. As I said, it will fill the mine pretty quickly. But maybe every 5 years or so, we go back and refresh the data that's stored in the mine. And yeah, we're excited about just about the future of software in general. So obviously, GitHub is working on lots of other projects that we're really excited about.
Wonderful, wonderful. Well, we are at the top of the hour here, and I know I have thoroughly enjoyed seeing this and hearing from you on this. So want to thank you so much for coming to speak to all of us. And I can see some claps of hands and thanks here. So For those of you, again, didn't get a chance to, I highly recommend looking at the video that is posted in Kiko chats and looking, I guess, at octoverse.github.com. So thank you again so much, Thomas.
Yeah, and it's also archiveprogram.github.com. And, you know, the archive program itself is open source. So if you will have an idea of what we should put into the check tree, you know, what documents somebody should find in 2,000 years that helps them to understand our world, please send us a pull request either to our manual or our tech tree, and you can contribute to it. So thank you so much for having me. It was fun talking to you all and seeing you on video and answering all your questions.
Thank you.
Yeah, thank you. This was a load of fun, Thomas and Alan. Thank you for running the show and fielding all those questions, particularly the technical ones that meant nothing to me. So thank you. It was really, it was a super experience. So I really appreciate it. I'm sure, and I know we all do.